A little more work on 5E. We've got a couple more videos and a little bit more to talk about with parallel and perpendicular lines that are graphed on the same coordinate plane. This is a review of what we talked about on page 32. We're on page 33 now. The lines are parallel if their slopes are the same. So if you've got two lines and their slopes are the same, I don't care what their y-intercepts are or what their points on the line are, if their slopes are the same, then your lines are parallel. Lines are perpendicular if their slopes are negative reciprocals. Or sometimes we say opposite reciprocals. If neither one of these are true, if the slopes aren't the same or the slopes aren't negative reciprocal of each other, then the lines cross, but they're not parallel and they're not perpendicular. They might look like that. They do not make a 90-degree angle, and obviously they're not parallel to each other. So remember, we said these are the three scenarios when you've got two lines graphed on the same coordinate plane. They can be parallel, they can be perpendicular, or they can just intersect somewhere along the line. Ha, that's a pun, somewhere along the line. Okay, so for each pair of lines, find the slopes and then classify as parallel, perpendicular, or neither. So these are both written in slope-intercept form, so we don't have to do any, we don't have to change these equations up, we don't have to do any calculation, we can just go inspect the slopes. So this slope of that line is 3, positive 3 over 1. This slope is also positive 3 over 1, so we can say the lines are parallel. Since both are in slope-intercept form, that's nice. And number two, it looks like they're both in slope-intercept form as well. We have this slope being 2 over 3. This slope is 3 over 2. And be careful here. They are reciprocals, but they're not negative reciprocals. So this does not say negative 3 over 2. So we need to say the lines cross somewhere. Lines cross, but they are not parallel and not perpendicular. Example number C, the slope is 5/7, 5 over 7 for this one, and on this one the slope is negative 7 over 5. These are negative reciprocals, so the lines are perpendicular. This page is going pretty quickly until we get to this problem, because we now have to go figure out what the slope of these lines are. Oh, that's still in, yeah, that's still y equals mx plus b. So the slope is 4. Here the slope is negative 4. So they're opposites, but they're not opposite reciprocals, because this is 4 over 1 and this is negative 4 over 1. So these lines cross, however, not parallel, not perpendicular. This is an interesting one. If you think about it, what are their slopes? So if you want to think about this in y equals mx plus b form, you get a slope of 0. Y is equal to 0x plus 3. That's not right. That is not right. Erase. Let's look at it. X equals 3. 1, 2, 3. That's a vertical line. Its slope is undefined. Here's x equal to 5. Vertical line, slope undefined. But they are equidistant apart. So these lines are parallel because both slopes are undefined. They have the same slope, an undefined one. And then this one, y equals 2, if you graph it, it crosses the y-axis at 2. And x equals 3, 1, 2, 3, it crosses the x-axis at 3. these guys cross and they are perpendicular. This is a little bit of a special example because one of them has an undefined slope and one of them has a zero slope. You might say, well, that's not really negative reciprocal, but these are just those rare occasions where you have something that doesn't quite fit the pattern. But you can always graph it like we did and see that certainly they're going to be perpendicular, just like we graphed example E and they were parallel. Thanks for watching. We'll do some more on the next page.